my son. Very good, very good. Can I have a kiss? Oh, just a little kiss from my boy.
So, I had to
What was
redo a
that?
video,
What was
but
that? Oh,
looking at
that's right.
the ruler
You're right. We
here.
should go to Frost some Lights.
The increment is owl, clearly,
owl, and I
and
come
you
out
need
of
to figure that out by logarithms of mice according to a week. That is life. That is the type of thing, and we do that by saying, well, moles or voles or mice are roughly 2 or 3 inches long, and colloidal intake on the thing, packing it all in there for, I need more than that. Maybe a diverse diet would be nice, but it's still got a colloidal, right? We got to do the triangulation here. So, looking at the cabin in the woods here, this ruler, which I scored off every inch. Inch is what's constant. Why an inch? Because it's roughly about the size of my thumb. That's easy for me to remember on a macro scale. We're looking at small things here. This lighter, I could say it's roughly 2 inches long, and it's about 2 1/4. 2 in 1, 2. Hold on. I don't know. 3/8, 2 3/8. So I generally knew that, and between the knuckle on my thumb and to the back of it, that's roughly the inch. And I'll gauge that out until the wobble's out, and I'm using an increment that's too small, where the boot becomes a foot. That is roughly, you take this ruler to your boot, and that's roughly 12 inches. Easy to remember, on a scale, walk it out, figure out your pace speeds. Those will become constant increments later. But at the macro level, the PCB board, the atomic level, when you start to have some problems on there is that inches are based in 4. 4s are going to be your perfect squares, your 1 times 2 times 3, or 1 times 2, 1 times 3, 1 times 4, 2 times 2, 2 times 1, 2 times 4, 2 times 3, 2 times 4, out to 4 by 4, 16. And that equals 100 in a perfect square. That's kind of one of those perfect integers based on the quarter that equals out to 100. A 10 of a log 10, which I'm still not totally convinced about, but I know there's magic numbers on the periodic table. Lead is one of them. There's double magic numbers on the periodic table. And those have a lot to do with those actions at spooky distances. So let's take that in consideration. We got all the inches out to 12 inches scored out across the system. I took a wire brush to the centimeter, so we got rid of that. And so we can actually score in some new measurements in here. First starting with the log 3. In this system, there's not really a log 3, and this is the base year increments. They should correlate to most of the symmetry before any orders of the operation start to say why I needed a clean log 4 instead of half, right? When it'll be 2/4 instead of 1/2, we don't reduce it, and we know that can be reduced down to 0, so there's not a real reason to go 4 inside of here. So we need a log 3. Log 3, 6, a ninth, right? Because there would be 27 altogether at ninths. There'd be 27, 9 lines, which on a log 3, you would need 27 for 1 inch. And we're saying that 3 inches is synonymous to 1 inch in that way. We're saying 2 inches is synonymous to 1 inch in that way. And any fractals below dividing 0 or 1 by 0 or something doesn't give you a decimal, right? Because we're saying from the whole numbers position, if you were ever going to divide it, it would be a point is what you get. And that point is going to base that down in log 10. The decimal out there to break that down. And so at log 3, you would look at some of these geometries. You might need to, in some of the number counts that I've been doing, you would say because any increment. There, I did it to scale to 4ths, right? Or 1/8 of an inch. But you really may need to keep clean geometry. Only an inch by inch system with a 1 in it, and then a 2 in it, at 2 inches, 1 by 2 inches, and 3 inches. And you break that down into a 2 by 2 grid system. On the first one, you're doing log 1, halves, quarters, and so on, because that's the subframe. In the bottom one, or in this case, 1/2 inch, with the markouts of 1/3 on this bottom part of the ruler, we can see that they measure up to very specific increments. They're 33, 66, and would be your two lines that you make to make three whole integrals, three whole log states, where the number 1, 2, 3 is correlated to scale, 3 inches, right? So inside of an inch, I got a 1 to a 3 ratio on a log that is fractaled. So what's next? What happens in that fourth corner, the bottom right? Well, that would be our log 5 potentially, or we could continue that with log 3. As you'll notice that there's a compression, much like one of those drawings out there where you'll see the multiples, right? That this times this will give you this, that there's some gaps, that they fractal, that much like a collision or something, it can't just go to that order. It has to go through the state of where that order correlates to before it would make the jump or that phase. And what I believe is happening is a geometry of an action at spooky distance. So whether we continue all log 3 across the bottom of this ruler as a fractal to make sure that we're getting measurements lined up for whatever mathematical system, the adjacent, the hypotenuse, or the opposite we're dealing with here, that works. Or we could just say for easy systems on an inch, if you needed it to be broken down in 3s, 5ths, 7ths, 11ths, or 13ths out to 5 inches, that you could use this ruler as a way to quickly diagnose what the log is inside of that inch while we're staying on. Now, Earth may not care about that, and the game being to get a clean geometry. Remember, that's going to be good for particles, chemistry, I'm sure, some types of engineering, I imagine. But as we continue that down, why couldn't you say, well, at a 3 by 3 square that way, that we go in the middle of this ruler, this 1 inch ruler, we draw a line from 1 inches with a log 3 system in the middle, close enough with a line that shows me on either indicator up or down between a log 1 and a log 5, or excuse me, log fractal, half, so on and so forth, that I'll have an inch on the top of the ruler, I'll have a log 3 in the middle of the ruler, and I'll have a log 5 at the bottom of the ruler, all within one side of an inch, utilizing what methodology I do. Now, we could even say that the log 3 would be on the left side, the 0 side, and the log 5 at the bottom, with a log 3 running through the middle of that ruler. And again, it's got to touch both sides of it, because when I'm making increments on those measurements, I needed to do binary work. I needed to do log inch or log 5, log fractals of those systems, and we don't want to push that past 16, much like on the inch here. What do we got? 13 is between 4 and 5. Then it would be 14's good, 15's good, 16's good, 17. So 3, 5, 7, 11, 13, 17, 19, and out to 7. You don't really need log 19 because we have 16. That fractal at this point in time puts it in a black hole. Too small of a measurement, where these, you could say a log 10, but that's inside of log 5. It's a fractal of that, but moving much like the inch, we're scaling up at that time, or scaling down accordingly. And that's a binary action. It's not really opposite. It's on a triangulation. So we're not talking right and wrong. We're talking about, even though the action was what I was supposed to do, it was the wrong sequence within that operation, or something along those lines. And it would not be as correct against the codex there to say that was what should have been done. Now, if the orientation say that's what should have been done, that's what was. That's what was done. You'd go looking at it and you would see the address of that DDoS's subframes, or magic numbers encoding, that says that's where the address was. That's where actually the correlation of that problem was. Not like, oh, well, the operations are all wrong. The operation may be fine. It's part of that. It could be that. But most likely, seeing that that hadn't gone to other Primarchs first, some address say we had common problems with this whole area, that manager's a dick, something. Whatever that was, that's that address. That's that magic number in actions and spooky distances we're talking about here. So it's interesting, I haven't really seen anything like that on the internet as far as this here ruler, or why it's not more mainlined, especially dealing with these magic numbers, multiples, divisibles, the fractal states inside of here.
That's just a little light control bird.
Catch you on the next one.